There are several different types of pipettes, and they operate a little differently. This is called a volumetric pipette. Notice it has a 20 on the midsection here. This type of pipette does only one measurement, but it does it very well. That is, that it measures very accurately 20 milliliters of solution. If you fill this entire portion of the pipette with liquid all the way up so that the meniscus is touching this line known as the mark, where Dr. Smithhart's finger is, we will have 20 milliliters. The other kind of pipette that you might be using in general chemistry lab is a graduated pipette. This pipette is a little different. It is similar to the burette in that you have an initial and a final volume, and you have to subtract to get the net amount of solution added. So you have to do two measurements with the graduated pipette, but only one measurement with the volumetric pipette. Dr. Smithhart is going to use this pipette to pipette 20 milliliters of the red solution to the receiving container, which is a beaker. We're going to need this, which is known as a pipette bulb. Before you use your pipette bulb, inspect it closely and make sure there are no cracks in it. Also, inspect the bulb to make sure there is a silicone liner. This adapter allows it to make an airtight seal with your pipette. For instance, here is a pipette bulb without the liner. This will not work. Do not even try to use a pipette bulb like this one. Make sure that you use one with the liner installed. To begin, we have a clean 20 milliliter volumetric pipette and a pipette bulb ready to go. So put the tip down into the solution. You can use the bottom of the container to your advantage. If you want to slow down the rate of flow of the liquid, you can keep the tip in contact with the bottom. But if you want to speed up the flow, then you can take it off the bottom. The pipette bulb is only to provide vacuum, not pressure. Never put the pipette bulb on the top and squeeze. Never screw the pipette bulb down tightly. That is what happens to the liners. Screwing it down too tightly will pull it out. Don't compress this while it is in contact with the pipette. We want to compress it, then put it on the pipette to apply a vacuum. That's what we need. You really need 3 hands to pipette, but since we do not have 3 hands, we're going to use the bottom of the beaker like a 3rd hand. Dr. Smithhart depresses the bulb and puts it on the pipette. Notice the pipette is vertical, straight up and down. Now, release the bulb and notice the liquid rising. If he turns it to the side, it rises up faster. Now it is speeding up. Now he is out of vacuum. So he pulls this bulb off, and notice, since it's in contact with the bottom of the container, the liquid is not really coming out very much. So he is going to just compress the bulb again, install it on the pipette, tip it to the side, and let it go again. Now you want to slow down when it gets to the narrow part, and usually you want to go past the mark and come back. He lets it overshoot the mark, and then he lets it fall back down. It is dropping slowly. Next, he gives it just a little more vacuum so he can pull it up some more. It passes the mark. Now he stands it up, takes the bulb off, and puts his finger on the top of the pipette. Then he will hit the meniscus, which is where he wants it. It is right on 20 milliliters. Transfer it over here and let it drain naturally. Do not help it out with your bulb, just let it drain. It is designed to drain aqueous solutions at room temperature just like this. This is a very accurate measurement. Notice that there's a little bit of solution trapped in the tip. What do you do about that? Nothing. You just leave it there. Don't try to force it out. It is 20 milliliters of solution with this little bit still stuck in the tip. Obviously, you want to make sure you clean the pipette up before you put it in storage. The next pipette that we will demonstrate is a graduated pipette. This one is rated at 5 milliliters in 1/10 increments. So if you look at this, you'll see between the 0 and 1 that there are 1, 2, 3, 4, 10 increments. That means we can definitely assign a value to the nearest tenth of a milliliter with this pipette. Let's say that we want to transfer 2.1 milliliters from our stock solution to our receiving container. You can start anywhere along this. There is even a -1 and -2 gradation, but just for convenience, we start at 0. If you want to transfer 2.10 milliliters, you need to go up to 0 and down to 1 mark past the value 2. You should be able to interpolate a value between the last 2 marks just as with the burette. So we are going to treat it very much like the volumetric pipette. Obviously, this pipette does not hold as much solution, so we do not need as much vacuum. Notice that there is a piece of cotton at the tip of the pipette. This is to try to keep the liquid out of the bulb and so prevent contamination of the pipette bulb. You will know that you pipetted correctly if this cotton remains dry. If it is not dry, then you will know you messed up and you probably contaminated some things. So be careful about this. Dr. Smithhart depresses the bulb and puts it on the pipette. Applying the vacuum slowly, he is going to go past where he wants to go. Removing the pipette bulb, he straightens up the pipette and puts his finger on it before it passes the point that he wants for his initial value. Now he can let the solution drain until it reaches his initial point, which is 0 milliliters. Now with the pipette reading exactly 0 milliliters, he's going to go to the receiving flask and release the pipette and let it drain while keeping an eye on the level and reading the meniscus. He wants to transfer 2.1 milliliters. He allows the pipette to drain down to that point, and when it is reading 2.10 milliliters, then that is the amount that he has transferred. You can take the remainder of the stock solution and discard it.